Hi, everybody. Welcome to today's fireside chat. Our topic is modernizing legacy buildings without the rip and replace. I'll get into our guest speaker who's going to join me today here in a second, but I just want to introduce myself. I'm Jim Hassman. I'm the President and Chief Revenue Officer of Blues. I joined Blues in 2021 and joined Ray Ozzie, who's the founder. Um, Back at that time, if you're familiar with Ray, you'll know that he was the creator, inventor, and CEO of Lotus Notes. He also was the chief architect, software architect at Microsoft and the inventor of Microsoft Azure. And after Microsoft and doing some work in the connected space around radiation monitoring around nuclear sites, decided to try to tackle this problem of solving, um, building a single system that could help customers connect products to the cloud and turn those products into connected intelligent services as easily as possible. So he's an amazing architect, an amazing inventor, and great to work for. Um, I'll give you a quick introduction on blues really quick, and then I'll introduce our guest from SkyCentrics. Let me see if I can share real quick. Just a couple of visuals for you. All right. Hopefully you're seeing the screen that says who we are. Blues is a device to cloud system that helps you build smart connected products. And effectively, what we've done is try to take a very radical approach to simplifying what it takes to integrate wireless hardware, data routing, and fleet management across connected devices. What do we do? We deliver data. People actually refer to Blues as the simplest data pump ever built. And so Tristan, who's the CEO and founder of SkyCentrics, will talk about how he's using that inside his own product, but we deliver data instantly, securely, and economically. We are in pretty much every industry. I don't need to read all these to you. Some of these we have many, many applications. The other day, I think we counted just in tractor trailers, in the transportation and logistics space, for example, we are in 17 different products on a tractor and trailer. So every time you pass one on the highway, Blues is all over those things. We focus on a couple of key areas of helping people with key business problems: downtime prevention, saving energy, reducing truck rolls, and reducing theft and losses. These are key use cases where you might see blues being used inside of products all around you in your daily lives. This is the blue system. On the left, you have these little modules called note cards. They come in different flavors. We have cellular, satellite, LoRa, and Wi-Fi. We have hybrids of those where we merge different radios together on a single card. Those are embedded and designed into one's printed circuit board or the electronics of their device, and they basically talk to the device and the device's sensors and package up these tiny little um, pieces of data like you see in the middle of the screen here. That's JSON data, which is very easy to read. You can see humidity, temperature, voltage. These are the types of things that the Blues product is used to send from the edge to the cloud. And then on the right, you see a screenshot of our cloud system called NoteHub, where all the data land, and customers are able to manipulate, transform that data, package it up to send it on to their preferred cloud instance. How it works: if you look from the top to the bottom, at the very top, you're going to have any sensor or actuator. You get to choose your own host, your own operating system on the host or RTOS. You can use any language you want to write your firmware and interact with the sensor data and the note card. Those data from the sensors are push through your host onto the note card, or what we call star note. That would actually be a satellite version of the note card. So over any radio network, the data land, if you're moving towards the bottom, in Note Hub, which is the Blues cloud fleet management environment where you do data routing. You can set up alerting and reporting. You can manage all your devices, all your firmware. You can do fleet management, and you have one harmonized user experience and API to get at all of your devices, even if those devices are used for different things or the devices have different configurations or settings. You're able to manage all of that through NoteHub. And then you're able to route that data to your application into any preferred cloud instance of your choice. So that's basically how Blues works. And a big piece of this, and I'll end with this, is that we've designed security at every layer, from the hardware layer to the firmware layer to the data transport layer, which is completely off internet. It's air gapped, it's tight. It lands in Note Hub where you can decrypt the data, re-encrypt it if you want, and send it on to its final destination. But we do have security built in at every step, at every layer. So that's just a quick commercial on Blues. Hopefully that didn't take too long. Now I'd like to introduce Tristan. He's the founder and CEO of SkyCentrics. I've known Tristan now for a few years. He's got a mega project on his hand. And so I'll let him introduce himself, what SkyCentrics does, and the products that he has and the ones that use Blues.
Sure. Hello, everybody. My name's Tristan de Frondeville. I'm the CEO of SkyCentrics. We sort of came from the utility space and we're the experts in a USB communication type stick for machines. The utilities realized about 15 years ago that they needed to have lots of machines out in the world use more energy when the grid is clean and less energy when the grid is dirty. Unfortunately, we were the experts at this USB port called the Eco port, right there, little weird looking thing, a big high voltage port for machines. So imagine being the experts in that port, but there's only a few thousand laptops or machines that have the port. So the big breakthrough was in January 1, 2023, Washington and Oregon mandated that every residential water heater have the EcoPort socket in the water heater. So now there's 100,000 water heaters a year going into that space. But as you can imagine, as a startup, we were tired of waiting for the machines to have a socket because we were experts at making the communication module, again, kind of a big module that plugs into this box or into that socket. So it turned out that commercial buildings were starting to get the requirement to have this socket for commercial building machines because those use a lot more electricity. They're super more interesting to the grid. And the commercial building equipment makers, big ones, didn't really know anything about grid signals that SkyCentrics had been working on for 10 years. So we invented the Skybox. So here's a Skybox, right? It talks the old languages of buildings that have been around for 60 years, Modbus, LAN, BACnet, KMX, all these weird languages that nobody's ever heard of because they were invented 60 years ago. Imagine trying to talk computer to computer, machine to machine 60 years ago when we barely had calculators with the little red line. All right, so once we made this Skybox and made it talk the old languages and give all these commercial building equipment makers a certified socket, and another certification for grid signals called Open Automated Demand Response. And I waved this earlier. It's going to be a little tricky with but there's the Blues card. There's the magic data pipe. And so what that does is it allows us to sell this and get grid signals to it. They have the EcoPort socket for future proofing and competitive vendor access. That's very exciting. People can put a cellular module, just like Blues has a different card for different things, right? Satellite, cellular, LoRa. This allows a machine to not worry about the communication path. Maybe they want low-cost cellular. Maybe they want a satellite in some instances. So that was good. And we started getting big machines having that EcoPort socket. But by that point, we had learned how to talk Modbus and BACnet to all the machines and buildings. And we discovered that buildings have less than 2% of commercial buildings are connected outside the building to the internet. So they can't be optimized for weather signals. They can't get those grid signals I just talked about. And the building owners themselves have to log in to their elevator system, their lighting system, their BMS, the HVAC system, everything. If you look at a portfolio manager, like a big real estate portfolio manager with 1,000 buildings, each building has their own people with 20 screens in front of them having to log into each system one by one. So we made a super skybox, a small little Linux computer, costs $500. You plug it next to any building machine or system that talks Modbus or BACnet or LAN, and you instantly see that system plus all the systems. So if we have time, I might dig into the details of a 5-year-old state of the art building that was an engineering headquarters building in Portland, Oregon, 5 years old, and it's everything net zero, sustainable, living building certified, which is even harder. And they had all those systems I mentioned: solar, battery, composting, toilets, and yet they didn't have everything visible in one place. So we put our super skybox in there. The only lucky thing is, instead of putting one on each floor, they actually had everything wired to one network closet. That was the one thing that a 5-year-old building got you. Everything wired to one place. Okay. And just for fun, I'm going to show you a few slides on this building. So here we
Yeah,
go.
most buildings aren't like that, obviously. So effectively, I'm listening to your story, and obviously, having known you for a few years, you guys have you've been able to create something that takes an old building with potentially old assets and give it life.
Right. Give it life. We like to say, free the machines, give them a
Yeah.
voice, let them talk. And obviously, what's really exciting is in the last 2 years, everybody realizes that AI can get involved. Well, what do you need for AI to get involved? We all know it needs to absorb data. If less than 2% of commercial building machines are connected to the internet, there's no data. We're freeing the machines and gathering that data from all the machines and being able to apply modern AI enhanced tools to this. So here's the building, right? 5 stories. You can see the solar, you can see the heat pumps. There's a room full of batteries down in the bottom of the building. We put our super skybox down in the bottom of the building in the network closet. And a 5-year-old building, what you're looking at right now is, after 30 days of being in the building, this was a heat map of the battery system. Now, red means it's fully discharged, and blue means it's fully charged. And this is midnight to midnight on the x axis, and vertically, it's 30 days worth. Every stripe is 30 days. So, in 30 days, how often was that battery fully charged? 4 days. What do you want to do with a battery? You want to charge it every night on cheap electricity, low cost, and that's what you see after a few months of working with them, because they had been running this for 5 years and they had no idea their battery system wasn't doing anything to lower their grid utility bill. Now they load it up every night until 8 in the morning. You can see it nice bright blue here, except Sunday. And then they spend the day using that battery during the expensive time of the grid to lower their grid costs. Again, can you believe it that this engineering headquarters, designed by them for 5 years, had this beautiful battery system that wasn't being used?
That's that's uh that's interesting. I spent a lot of time in utilities and in energy efficiency programs and demand response programs and distributed generation programs for many, many years. And, this is still largely an unsolved problem, especially at the utility level. They're only moving things forward with incentive programs. So is that what caused you to kind of go at the commercial building level versus the utility side of this?
Yeah, Jim, that's exactly right. So we still sell these. They're going into water heaters in Washington and Oregon and a few other forward-looking utilities in the United States. That's exciting. We're experts at getting grid signals to machines, but we've always known that even though commercial building machines, there's fewer of them, it's a lot bigger electric load. So if you can put one of these boxes next, I'll give you an example. We just did a building, it's 100 apartments, and their central system heat pump water heater, and heat pumps are more efficient. Remember, one of our mottos is all these heat pump systems that everybody loves, they're more efficient, they provide heating and cooling, but they're more complex. So they should all have a Blues note card and a Super Skybox or Skybox, making sure that they're running efficiently. And the minute they're not, you go in, you do a mild fix, just like your car tells you there's a little low tire and you get it fixed before you blow out on the highway. So, in terms of going after these large building loads, it's super exciting. It's always been hard to do because of those old protocols and the very proprietary nature of the big incumbents. I won't mention any names, at least for now. And so, yeah, we're already to this building that you see, we've delivered grid signals and working with the local utilities so that they can benefit from this huge battery system. They can benefit from this very modern building participating in the grid. And the utilities are super excited about being able to do this for commercial buildings, which they haven't been able to do. So, to finish that little thing, one central system heat pump for 100 apartment buildings provided the same load flexibility as 200 homes with a regular water heater. And let me just jump to this because I just want to mention it, right? Not only are we a modern tech stack put on top of legacy buildings, but we're working with the Linux Foundation where we're releasing part of our code into the open building stack. So in June of last year, the Coalition for Smarter Buildings merged with the Linux Foundation and essentially created Linux for Buildings, of which we're one of the leads with these Linux computers that we put in buildings to be able to break open this proprietary, expensive, custom nature of buildings and essentially to sort of, it's like going from mainframes to desktops to mobile. What was the big difference? Those of you who are old enough to have white hair like me, you sat in front of a little terminal at college and you had about 10 apps, maybe a spreadsheet app before Lotus Notes, and then you had maybe a word processing app, and that was it. And you had to go to the computer room. And then you got desktops and laptops, and that's where Lotus Notes came in. A lot of people could write new applications. So you had an explosion of innovation. And then you went to mobile, and your high school teenager can write apps for mobile. And that's what we're creating with this Linux Foundation project is opening to modern Kubernetes, tech stacks, et cetera, so that everybody can write apps for buildings. And finally, buildings use 35% of the energy and emit 35% of the carbon. It is a big deal. And just being able to have a little bit of orchestration, a little bit of visibility, we lower the utility bills by at least 30%. We give people initially very powerful AI enhanced tools for the engineers to be able to monitor things and fix things remotely. And finally, we're even heading towards a world where we can do AI enhanced portfolio capital planning because we're getting all the data from all the systems. We're able to predict equipment failures, et cetera. So super exciting.
So there's, the heat pump thing is interesting because, especially in Europe, the explosion of heat pump installations is everywhere. It's government mandated in some of the countries. These are brand new assets rolling off the line. And what would be your guess as to how many of them roll off actually with a form of reliable connectivity built into the device? 0%, 10%, 50? Like, what do you see out there?
Zero in America.
Yeah. It's amazing to me that even with new assets that are being designed and manufactured literally today, they come off the line, they get shipped somewhere, plugged in.
Jim,
It's
you
like,
should be calling them all up. They should all have a Blues card, but then they wouldn't be buying skyboxes.
right? Hey, speaking of the Skybox, we've got a really mixed audience here. We have some commercial building people on the phone, we have utility people on the phone, we have developers who build connected systems, we have like press people, like there's the varieties. We may even have some Gen Z people on the phone. When would you need to use one Skybox for an asset or a group of assets versus multiple? Like, help us understand the context of how that decision gets made.
Well, first of all, I like the idea of multiple, right? So I've already mentioned how this modern building, and now you can see it, we're piping the data to Autodesk's digital twin software. So there's the building in a digital twin environment. So which skybox to get? What does it do? What's the difference, right? So these skyboxes right here are made so that it just goes next to the equipment. It's got an internal Blues card to provide instant cellular communication, but then it has that EcoPort socket for future proofing for multiple vendor access. Maybe somebody wants to do satellite or LoRa and we only have cellular inside. So that's the idea behind the Skybox. But it's meant to be inexpensive, right? It's meant to be all these OEMs. You can go to these certified product lists like the EcoPort socket and see the different OEMs that are certified for grid signals because they use this. So we wanted to make it inexpensive, which means we don't have a full powered Linux computer on there. We have a low cost Linux computer. The Super Skybox is a full Linux computer operating system. And frankly, we're making different versions of these, including all the way up. We think that universities are going to be buying a $20,000 Super Skybox with 4 AI at the edge, NVIDIA chips inside. There, you can buy a Linux computer like that, put our software on it, and then run a whole bunch of buildings at a university or portfolio level off of one super duper Skybox. Sorry
Got
to
it.
get a little cute.
Yeah. Um, but the end customer who might buy one of these, your most basic version of the Skybox, they don't need to be a Linux programmer, right?
Oh, they don't need to do anything.
Like,
They
what is
literally,
how long does it take to get one of these things, take it out of the box, connect it to an asset and see data flowing? What does that look like?
great. So these are already made. They're shipping with the OEM product, right? It's a SKU that you can buy so that you can get the grid incentive. So it's already made. You plug it in, it gets a little blue light. We call it getting to blue. You're connected to the cloud. That means you have a
I
live
like it.
cellular signal and you're ready to go. You got to blue. Because SkyCentrics is, we have our blue logo. Now, what's interesting on a commercial building like this, Jim, just to show you how crazy it is. So we put the first one in July, and we were meeting once a week with the engineers, and they had to go through their documents, their submittals, their architectural drawings, their Revit Autodesk drawings. And it took us about 2 months to get every piece of equipment through the Super Skybox Linux computer up to our cloud. So they were on a national webinar in January and they said, hey, SkyCentrics put the first box in July, took us a couple of months to do everything. I just this morning, the engineer at this building, I got a new Super Skybox with new software. It had a 10-page manual. I plugged it into my network. I read the manual. I clicked 3 buttons, and an hour later, all the same data was in the cloud and visible.
That's great. Which leads me to an economics question. Because we talk about the install speed, but on the economics side, your claim that the solution is 10x less expensive and has 10x more functionality. I think anytime anybody sees somebody use 10x or 3x or 5x in a tagline, they're like, yeah, 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 whatever. How do you back up that claim?
Sure. All right. So here is the 10x more features, right? So here's your building management system right here. Can everybody see my slides still?
Yep. Yeah,
All
we
right.
see.
So here's the building management system right there. So there it is. And I mentioned how you said, hey, multiple devices. So recently, we've been telling the engineers that the new Super Skybox they put in can act, we're actually going to start doing orchestration level control where we use the battery. I don't know if anybody knows this for those in the utility space. 40 to 70% of your utility bill, electricity bill, is what's called a peak demand charge. It's not how many electrons you use, but it's what was your peak? Because to be fair, the utility has to make sure that if there's 10 buildings, they all become data centers, then, they need to have a substation node big enough to handle 10 new data centers right there. So the peak demand charge 40 to 70% of your bill. And we're going to start using the battery system, the solar, and everything just to reduce the peaks, just to make sure not all the machines are on at the same time.
Hmm.
And that supervisory control and orchestration layer, these are $500 Linux computers. The current solution for buildings, they don't even roll out of bed unless it's a $20,000 job. We were talking to a mechanical electric plumbing contractor that's a public company. They have 8,000 employees. When we told them that it was $500 a box and, a certain monthly fee, they laughed. They said it's under $1,000 for building. Now, a lot of buildings, they say it's cheaper to put 5 boxes, one on each floor where the machines are, rather than take the labor to drill the wire down to the bottom
Yeah,
like we
yeah,
did
yeah.
for this building.
No one wants to pull cable if they don't have to.
Yeah, exactly. So, more blues cards out in the field. So that's a little bit around the economics. So let me just finish. This is the why are we 10 times more functional? That building management system, that's all it does. It doesn't get much data from the other things, about half the other things, but it's expensive. Every data point through a BMS is used to be $1,000 per data point. It might be 500, but it's not 5 or 10 like
Yeah.
we are. Okay, so more functional, right? You see everything, plus you apply artificial intelligence because it's a modern tech stack. I think I've talked about the more functional. And then the 10 times less expensive, I've talked about the incumbent. I won't mention any names, but there's one company that is sort of known as making the box that you put onto a Siemens building, another box from the company on a Johnson Controls building, and now you can see your buildings in one place if you log into each one, et cetera. So, again, this company laughed when they heard it's less than $1,000 per building. So $20,000, less than 1,000. We're being conservative, Jim. We didn't say
Yeah, you
20.
can.
It's
Well, it's not, it doesn't sound like it's just marketing then, because some people do use the 10x or the 5x just to, there's no claim behind it. But you mentioned AI, and I think we would be remiss if we didn't talk about AI. If people aren't in, if people aren't enabling or embedding AI into their solutions today, they're not going to make it. I mean, that's not my opinion. It's like everyone's opinion. Let's talk about it specifically with the Skybox. And let's talk about, people are familiar with the chat GPTs of the world and the Claudes of the world and natural language processing. Now people are starting to get this concept. People are hearing about agents or agentic AI. How does all this fold into what you're doing?
Yeah, what a great question, right? So, number one, how did we ship a Super Skybox that in 1 hour did what took months before? Most of the months before was the engineers of the building grinding through documents, making new spreadsheets of the data tables. That's something AI can do. So, what have we done? We allow them to upload all of their blueprints, architectural documents, Revit files, 3D files, all the any spreadsheet that they've ever done to their building, plus the manuals. They just say, "Hey, this is the machines we have here," and we ingest that, and then we use that all those documents as part of our BACnet and Modbus data point discovery process. So that's how we changed it from months to hours. Makes sense, right?
Yep.
Why should the engineer by hand, be then we made it so that we have a large language model that we've adapted for buildings, and you can now go and do a natural language query on our Dream platform. Pretty catchy name, right? It's called the Dream, Demand Response Energy and Asset Management. They've uploaded all their documents. They can type any question that before took them 10 minutes to grind through the document. For example, what is the Modbus register address of the set point in room 505? And they now type that in a natural language query on our platform and get an instant answer. What used to take them 10 minutes now takes them 5 seconds. Okay, so that's the basics, right? But as you know, if you want to do agentic AI, so we're clearly getting all the data in one place. We're working with the national labs and the Linux Foundation to apply more open standards, right? So there's something called 223 for the data tagging, so it's harmonized. And then there's something called 231, which is open standard control sequences that tries to take away the secret sauce, which wasn't that secret, but was proprietary, of the big incumbent controls vendors and say, hey, let's have open standard control sequences so that everybody can see what they're doing. So we're bringing that to the buildings. And then finally, when you are able to have all the data from all the systems, you can apply not only the agent to orchestrate to weather and grid signals, to participate in the grid, what's called a grid interactive efficient building, and to be able to do massive data prediction on when is my machine going to fail, and maybe capital planning, because if you can reduce how often a machine is used, you extend its total useful life. You don't have to spend that big capital replacing a big piece of equipment. You can extend it and you can plan for it and know when you're ready to do it, instead of a emergency break fix, which most of the time you have to bring a crane to this kind of a building. You have to reserve the crane. If it's an emergency fix, it's very expensive to get the crane that day, etc.
Yeah, you mentioned proprietary a few times, and I was in a um, workshop session last week talking about the future of semiconductors and photonics, and you had all these PhDs standing around the room that represented different organizations. And because of AI, all of this that's proprietary, it's our secret sauce. It's all being forced to break down because if you stand there and say, I will be proprietary forever, somebody's just going to make the assumption then I can't use you for AI. Sorry, I'm going to have to replace you. And so I think it's awesome what's happening in the space. There are walls just coming down like all the time on this. Um, we've got just a little over 10 minutes, and this we do these fireside chats every month or every 2 months. They're always well attended. This one had a ton of questions that got sent in before the session started. So for those that took the time to write us a question, I want to get to as many of these as we can. And let me just check to
I'll try to be
see.
short and sweet on the answers.
Okay. All right. I'm just going to go in order here. The first one, I'm going to leave names and company names out. So if this was your question, pay attention. Um, Any thoughts on optimal models for feeding IoT data to AI agents?
Yeah,
This is
absolutely.
a loaded. You might have a response. I have a
No,
response.
I'll be
Let you
short
go
and sweet,
first.
right?
Yeah.
We're, like I said, we're working with the national labs to do these open standard semantic modeling 223 and 231 on the control sequences. So we are literally working with Pacific Northwest National Lab on this building to pull data from the Revit model. What's been interesting is historically there's tons of data inside the architectural 3D diagram, and then you can see a video at the webinar where he took only an hour, where the engineer says, look, we take that beautiful 3D model, we print out tons of PDFs and blueprints in 2D, and then they get rolled and filed in a corner somewhere. So all that beautiful contextual data disappears. And we are doing what's called BIM to RDF. RDF is semantic triples. We're getting real technical here, but RDF is critical in the AI space so that the machine can know what's going on. And then we're generating all that AI agentic stuff that we're doing with an MCP server. That's a big deal, classic in the AI space as
Mhm.
well. So yes, it's happening.
I would say from a blues perspective to answer this, looking across all of the ways that blues, all of the products that blues gets used in across oil and gas, energy, agriculture, transportation, logistics, like all of it. I would say I don't know exactly on a use case by use case basis what the optimal model is, but I can tell you what the optimal model is not. Okay. The optimal model is not to stream everything to the cloud, to the AI agent, unless you're willing to absorb the costs associated with pipe everything up, run everything in the cloud, and then pipe inference down. The optimal model, and we don't see everybody do it at their first swing, okay, but eventually the optimal model is to figure out what can I run on the edge What inferences can I push up? When do I need to resend a good statistical sample size of data to retrain old models or build new models and then push those models down to around the edge? That is, to me, that's optimal. Again, like I mentioned at the beginning, I came from the AI space. I was there really early. We saw people banging their heads against this question for a long time, and they still do. So that would be my question. Part of it's my personal bias, and part of it's what we're seeing at Blues.
Well, you
Um,
heard me mention that $20,000 Linux computer. So this, as you can see, it's a little bit high, right? So we have the Blues card as a hat, and then we have an AI Edge chip as a hat. So we're doing
yep,
exactly that, right? And then we're using a bigger version of the Super Skybox that can run actually a fairly small large language model on the box. Uh, and so we're putting AI at the edge and then letting the building send much fewer points than what it takes to sort of run the building or commission the building, so that you're minimizing your data up in the cloud. But AI at the edge is critical, and to be able to do that, you need to first digitize the analog proprietary information that you find.
exactly. There was a question that I did a little bit of research on before this call. The question was, are sensors like strain gauges used? Um, I would say this, strain gauges can be used in a design using, if you're using Blues as your communication module, you can use a strain gauge with that design, but my but is you will likely need a proper analog front end between the strain gauge and your host MCU, but that it can definitely be done. So I'll just leave that question as that. I
If
don't know.
anybody knows a strain gauge that's got Modbus or BACnet output, just put a Super Skybox next to it, and you'll be up and running into that
Up and
day.
running. Um, Tristan, are you working with residential multifamily conversions?
Multifamily is what we call the low-hanging fruit sweet spot. Multifamily universities, big portfolio owners of multifamily. Multifamily typically doesn't have a building management system. They're all dying to switch their water heating to heat pumps. Call us up. We love multifamily.
Great. Best solar IoT partners. I will tell you who Blues's IoT partner is, and they actually use Blues to manage to monitor their solar panels. So they are a partner and a customer. It's a company called Voltaic Systems, and they've been growing like crazy since we met them. But great Blues partner, and if you guys need a connection, let me know.
All right.
Um, okay, this one I had to look up. How would our IoT services at Spinergy fit with your services? Is there any synergy? Tristan, I don't know if you had chance to look this one up, but they build a bunch of solutions that are LoRaWAN and different things that connect to things in buildings. I'm not sure if this question was intended for Blues or for SkyCentrics, but to the person who sent this question is maybe just hit me with an email after this, and we'd be happy to set up a call and talk about what the possibilities are. Because honestly, we don't have a lot of information. Um, okay, this one's for Tristan. I have a plug-and-play solution for wireless IO connectivity, applicable to various areas, including smart building environments. Um, it was a statement, I guess, but maybe we could
Jim,
talk
I'm
a little about.
assuming, yeah, maybe I'll just put my email up here. Oh, no, usually I have it. So I'll put my email up here, info at SkyCentrics, and, send us something on whatever you got. We'll look at it.
There you go. And if the question was intended to ask if there are any plug-and-play solutions, you definitely saw Tristan's examples today, but he can connect you with more. Um, Tristan and I both covered this, but the question is, I note you mentioned cellular IoT as a connectivity solution. Are there other forms of LPWAN options? If not, why not? I would just say our multi-radio architecture allows you to not have to worry about your design or your firmware as it relates to what radio is needed for what specific installation. This little note card form factor here uses an M2 connector. So if you have an M2 connector designed into your PCB or multiple M2 connectors, you're able to not have to worry about that question really because this little note card comes in all of the different radios that I mentioned, and you can kind of make that choice at deployment time.
Yeah, and we've explored, for our central heat pump water heaters, when they install four in buildings that are next to each other, putting LoRa in a skybox so that there's one cellular, but there's four LoRa talking to each other. And the one other thing I like to close up, at least close something that I said, which was we are doing N+1 resilient supervisory control on these Linux computers now. What does that mean? That means you can put three in the building like I showed you. They're running that supervisory control layer, the orchestration of all the systems. And if one of them goes down, you have two others providing backup. And when we presented that to the engineers 2 weeks ago, they said, "Oh my God, like there's no building with two building management system control panels. There's no building with two lighting control panels, let alone three." So that's another thing that you get with a modern tech stack, right? Super IT based, resilient backup.
Awesome. Um, Next one is interested to hear about low power modes and running Blue cellular solutions off of batteries for 5+ years. I will just say this. We have customers who have this design center is what I'll call it in their product, okay, today. But
Yeah,
there are a
we're
lot.
lucky we don't need it, but
You guys are powered on. But
we got juice.
if you're running off batteries, okay, and I don't, there are lots of kinds of batteries out there. Um, it all comes down to your design center, what your firmware is doing it, how often it's doing it, how many times you're booting up and powering down the note card. All of those are power draws. So a lot of it comes down to how the actual what it's doing. Um, but we'd be happy to do a design review with you at no charge if you want us to help look at that. So for the
And
person,
let me say that Blues is an amazing partner. When Jim talks about design review, I mean, they are incredibly helpful to get your project off the ground.
we're highly incentivized to help you succeed. Otherwise, our business goes nowhere. All right. Last two for Tristan. This looks like a monitoring system. Is it a true BAS?
Yeah. So, as you can tell by the supervisory control layer, let alone the orchestration layer that we're doing, it's a two-way monitoring and data control system. You can change anything on any set point anywhere in your system. Is it a true BAS? Well, BASs have a lot of details in them, and we're not trying to replicate that. So we've partnered with some second tier BAS providers, and they're happy to deliver the details of the VAV controller and the little connection to the fan boxes and the fan coils, but they're happy to cede to us a supervisory control layer because we can connect to everything in the building, not just the HVAC. So we're going to market with those partners. It's very exciting. We're not trying to immediately on day one replicate every BAS functionality. We'd rather partner with the people who are happy to cede us the high level controls. Hope that answers your question.
And last one before parting comments would be, will older BMS standards ever be replaced? BACnet, Lawnmark, KNX, Niagara, Modbus.
So the good news is, it used to be that BACnet is a big one, and BACnet IP wasn't seen to be as secure at what's called BACnet SC, but you were going to have to do a lot of labor and buy new equipment to do BACnet SC, Secure Connect. And now you don't have to do that. You can put a cyber secure Linux computer into your building, connect to your old BACnet stuff, and see it all. So we're glad that all these Modbus BACnet exist because otherwise we wouldn't be able to do what we do. Um, but will they all be replaced? Well, we've worked with OEMs in the skybox field, and they've tried to become MQTT savvy, and they kind of just fail. So it's hard, but everything gets replaced eventually.
Yep. All right, we are at time. I know we're going to go over a little over, but I do want to close this out properly. Tristan, any last comments, advice, plugs that you might want to make?
No, I told you how fun it is to work with blues. We just really appreciate everybody who attended. Thank you very much.
Yeah, Tristan, thanks for your time today. It's always a pleasure. I love your energy. It's all for those of you that are just meeting Tristan for the first time today. He's got this energy all the time.
Even
And
with a broken leg from
he's got a
skiing two
broken
weeks
leg
ago,
right
by
now
the way.
from a skiing accident this year. But Tristan, thank you so much for coming on, sharing what you guys are doing. It's super cool. For those of us that like to nerd out on this kind of stuff, what you're doing is really, really cool. And you are solving some really hard problems that people don't have to worry about anymore.
All right,
Um,
free the
uh,
machines.
I do have a plug. If you're curious about trying one of these things out, um, we Tristan can hook you up, help you show you how to buy a Skybox and get it installed and actually try one out. That to me, that's the plug. Like there's no more trying to sell people. Like just get them the stuff and let them try it. Same with blues. If you've got a product that you want to see if you can connect it, see what the economics of connecting it are based on your use case, let us know. We have little dev kits that can help you get started and experience what it's like working with blues. It's like 30 minutes and you're already connected. It's just JSON based interface. You don't have to worry about the carrier. You don't have to worry about SIM cards. You don't have to worry about modems. You don't have to worry about AT commands. You only have to worry about how you're going to embed this little note card into your design and activate it. That's it. So anyway, that's my plug. Thank you all for attending today and for your questions ahead of time. I know we didn't get to everybody, but hopefully we got to ones that I thought Tristan and I could answer for today. So anyway, thanks all. Have a great week.